Hello viewers. So in today's class we are going to take up an important integral which involves greatest integer function, right? So here we have to integrate this greatest integer function 2x square minus 5 from 0 to 1, right? So here we see that the lower limit is 0 and the upper limit is 1, right? So here we see that x belongs to the interval 0 to 1, right? So when x belongs to the interval 0 to 1, then 2x square minus 5, it belongs to the interval minus 5 to minus 3. How? Because when x is 0, then the value of 2x square minus 5 is 2 times 0 square minus 5, that is minus 5, and when x is equal to 1, then the value of 2x square minus 5 is 2 times 1 square minus 5, that is 2 minus 5, that is minus 3. So when x belongs to 0 comma 1, then 2x square minus 5 belongs to the interval minus 5 to minus 3. Now let us represent this fact on the number line, and we see that 2x square minus 5, it belongs to minus 5 comma minus 3, right? And we see that the integers which lies between minus 5 and the integer which lies between minus 5 and minus 3 is only minus 4, right? So when x lies between 0 to 1, then 2x square minus 5, it lies in the interval minus 5 to minus 3, and the only integer which lies between minus 5 and minus 3 is minus 4, right? So now our aim is to express this greatest integer function as a piecewise function. So here we see that when x lies in the interval 0 to 1 and 2x square minus 5 lying in the interval minus 5 to minus 3, then we have two intervals here. That is, one is from minus 5 to minus 4 and the other is minus 4 to minus 3. Clear? So we'll write this greatest integer function 2x square minus 5 as a piecewise function in the intervals minus 5 less than or equal to 2x square minus 5 and less than minus 4, and the second interval is minus 4 less than or equal to 2x square minus 5 and less than minus 3. Clear? Now when 2x square minus 5, it lies between minus 5 and minus 4, then the value of greatest integer function 2x square minus 5 is minus 5. Clear? Due to the definition of greatest integer function, right? Similarly, when 2x square minus 5, it lies between minus 4 and minus 3, then the value of this function, it would be minus 4, again due to the definition of greatest integer function, right? So here how we have got this minus 5, because 2x square minus 5, it lies between minus 5 and minus 4. So let us take a value for the example. Suppose we have here say minus 4.5, right? Then what would be the value of this function when we have minus 4.5? Clear? So then we'll have minus 4.5 because 2x square minus 5, it lies between minus 5 and minus 4, and due to the definition of greatest integer function, we have the value of greatest integer minus 4.5 is minus 5. Clear? Similarly, when 2x square minus 5, it lies between minus 4 and minus 3, then we have suppose here we have a value, say 3.5 minus 3.5, then greatest integer minus 3.5 is equal to minus 4, right? So that is that's how we write the value of this function. Okay, so now our next aim is to express these two inequalities in terms of x only, right? Or we'll solve these two inequalities. For example, the first one is minus 5 less than or equal to 2x square minus 5 less than minus 4. Now we'll solve it. Clear? So what we'll do, we'll add 5 throughout, then we'll have minus 5 plus 5. Here we have 2x square minus 5 plus 5, and here we have minus 4 plus 5. Clear? So here we have 0, here we have 2x square, here we have 1. Now dividing throughout by 2, we'll have x square here, here we have 1 by 2, and taking the square root, we have 0 less than or equal to x, but less than 1 over the square root of 2. Clear? So this inequality is now equivalent to 0 less than or equal to x, but less than 1 over a square root of 2. Clear? Similarly, we'll solve this inequality. So here we have minus 4, and then we have 2x square minus 5 less than minus 3. Now adding 5 throughout, we have minus 4 plus 5. Here we have 2x square minus 5 plus 5, and here we have minus 3 plus 5. So here we have 5 minus 4, 1. Here we have 2x square, here we have 2. Dividing throughout by 2, we'll have 1 by 2 here. Here we have x square, here we have 1. Clear? Now taking the square root, we have 1 over square root of 2 less than or equal to x less than 1. Clear? So now this inequality is equivalent to 1 over 2 square root of 2 less than or equal to x, and here we have less than 1. Clear? So now we'll express this integral I, right, in terms of the sum of these two integrals, that is by using the additive property of integrals, we can split this integral into two integrals, that is from minus 5, here we have 0 to 1 over root 2, and then we'll have the integral from 1 over root 2 to 1. Clear? So here we have 0 and here we have 1. So here we have 0 and here we have 1. So we have written this integral as a sum of two integrals. So here we'll have greatest integer function 2x square minus 5 dx. Here also we'll have greatest integer function 2x square minus 5 dx, right? So we have these two integrals, let us say I1 and I2. Clear? So now the value of this greatest integer function 2x square minus 5 is minus 5 when x lies between 0 to 1 over square root of 2. So here we have 0 to 1 over square root of 2, and here we have minus 5 dx, plus we have the limits from 1 over square root of 2 to 1, and the value of greatest integer function 2x square minus 5 is minus 4 when x lies between 1 over square root of 2 to 1. So here we'll write minus 4 dx, right? So now we can evaluate these two integrals. So here we have the integral of minus 5 dx is minus 5x, and the limits are from 0 to 1 over root 2. Here we have the integral of the indefinite integral of minus 4 is minus 4x, and the limits are from 1 over root 2 to 1. Clear? Now we can write this expression as minus 5, 1 over root 2 minus 0, then we have minus 4, and here we have 1 minus 1 over root 2. Clear? Now I can be written as minus 5 times 1 over root 2 is minus 5 over root 2. Then we have minus 4 times 1 is minus 4. Then we have plus 4 over root 2. Clear? Now these two are like terms, so we have minus 5 plus 4 over root 2 minus 4. Then I can be written as minus 1 over root 2 minus 4. Right? So this is the required value of this integral.